Another challenge facing the zinc countertop industry is that current construction assemblies are literally ripping some products apart. I discussed in a previous post how substrates or cores from the slip cast deposition technique are made of assemblies of plywood and hardwood. Anywhere a seam is present, so between the two bonded sheets of plywood, the trim on the front, the backer, or the back of the drink rail, dissimilar expansion and contraction from natural grain patterns are creating the potential for micro fissures in the finish to form. The integrity of this assembly is particularly important for the deposition applied projects, which rely on mechanical bond. Often, this bond is most vulnerable on edges of plywood because the denser end-grain veneers have a poorer bondability than the face veneer surface. This typically happens along the entire back edge of commercial tops. It also happens in the corners of the drink rail, where coating thickness and integrity are most needed and the hardest to achieve. If another veneer is applied over the end grain, the seam only moves to the top and bottom of the project. There are always multiple vulnerabilities to assembly build-up construction. Compounding this problem is the use of pre-made, outsourced trims, which may only be available in harder species such as maple, oak, or beech. These trims that face the patron leave themselves more vulnerable to damage because of their greater density, which results in poorer bond. They also expand at different rates than Baltic birch veneer and poplar, and most importantly, because they are all oriented in different directions, they expand in dissimilar ways, which stresses the zinc coating. Once that bond is broken between the metal and the wooden substrate, particularly in thin areas or areas of challenging bond, water will become an issue. Unfortunately, this happens at the worst locations, not on the top surface itself, but in and along the drink rail and near the service and patron edges which face out. As discussed previously, water infiltration can lead the way for bacterial colonization and substrate breakdown. The core or substrate will literally begin to rot and host bacteria. Often, the damage is under the zinc, and no amount of cleaning by staff can stop the inevitable demise of the substrate. A major challenge facing the industry today is figuring out the detailing and material selections that best suit the construction of your project.